Hello students, we are studying Internet Protocol Security, it is IPsec. In previous video, we have studied about inbound and outbound security association and the different databases maintained for that and the security policy associated with every inbound and outbound security association. Now the next part which you have to study here is Internet Key Exchange, and under that Internet Key Exchange we'll be studying Internet Security Association and Key Management, that is ISAKMP Protocol in this video. So the Internet Key Exchange Protocol, it is designed to create both the inbound and outbound security association for IPsec. So as we have already discussed that when a peer need to send a IP packet, it consults the security policy database to see if there is a security association for that type of traffic. So if there is a security association, then the policy will be applied and the packet would be sent. But if there is no security association present in the security association database, then IKE is called to establish that security association. So that IKE is nothing but the Internet Key Exchange Protocol, which will be used to create both the inbound and the outbound security association for that particular traffic. So this IKE is a very complex protocol. It is actually based on three other protocols. That is OCLE protocol, then SKEME protocol, and the Internet Security Association and Key Management, that is ISAKMP protocol. So here in this video, we'll be studying ISAKMP protocol, and in the next video, we'll study the OCLE protocol. So this ISAKMP is designed for key exchange, and it uses the public key encryption for the entity authentication in a key exchange protocol. In the further slides, we'll see that one of the method used by IKE is based on SKEME. Then this Internet Security Association and Key Management Protocol is a protocol which is designed by National Security Agency, that is NSA, that actually implements the exchange defined in IKE. So it defines the several packets, protocols, and parameters that allow the IKE exchange to take place in a standardized formatted messages to create security associations. So we will discuss about this ISAKMP in this video. So this is an ISAKMP general header. So this ISAKMP protocol is basically designed to carry the messages for the Internet Key Exchange Protocol. The format of general header is shown here in this diagram. So let us look into the different fields of this header. So the first one is the initiator cookie header, initiator cookie field. So this is a 32-bit field which defines the cookie of the entity that initiates the security association establishment, the security association notification, or the security association deletion. Then the next one is the responder cookie. This is again a 32-bit field which defines the cookie of the responding entity. The value of this field is 1 when the initiator sent the first message. Then the next payload field, it is an 8-bit field which defines the type of payload that immediately follows the header. And we are actually going to discuss about the different types of payload in the further slides. Then next is the major version. So this major version is a 4-bit version which defines the major version of the protocol. Currently, the value of this field is set to 1. This is IKE version 1. Then the next one is the minor version. This is a 4-bit version, defines the minor version of the protocol, and currently the value of this minor version is 0. Then the next field here in ISAKMP header is exchange type. This is again a 8-bit field which define the type of exchange that is being carried by ISAKMP packet. We have discussed the different exchange type in the previous video. Then the next one is the flags. This is again a 8-bit field in which each bit defines an option for the exchange. So far only three least significant bits are defined. The encryption bit, when set to 1, it specifies that the rest of the payload will be encrypted using the encryption key and the algorithm which is defined by the security association. The commitment bit, when it is set to 1, it specifies that the encryption material is not received before the establishment of security association. And the third one is the authentication bit. When it is set to 1, it specifies that the rest of the payload, though not encrypted, is authenticated for the integrity. Then the next field is the message ID field. This is again a 32-bit field and it is a unique message identity that defines the protocol state. So this field is used only during the second phase of the negotiation and is set to 0 during the first phase. Then the last one is the message length field. Because the different payloads can be added to each packet, the length of the message can be different for each packet. So this 32-bit field defines the length of the total message, including the header and all the payloads. So these are the different fields of the ISAKMP header. Then there are different payloads. The payloads are actually designed to carry the messages. And the table is describing you about the different payloads. So none, when the type is 0, it is none. It means that it is used to show the end of the payload. SA is used for starting of the negotiation. Then the next one is the proposal. It contains the information used during security association negotiation. Transformation defines the security transform to create a secure channel. Key exchange carries the data used for generation of the key. Identification, it means it is carrying the identification of communication peers. Certificate, it means that it is carrying a public key certificate of the peer. Certification request means the payload is carrying the request for the certificate from the other party. Hash means it is carrying the data generated by the hash function. Signature indicates that the data which is generated by the signature function is there in the payload. Nonce means it is carrying the random number or the nonce. Then notification, it means it is carrying some error message or status which is associated with the security association. Delete is indicating that the payload is carrying one more security association that the sender has deleted. And vendor defines the vendor specification extensions. So all these payloads which we have seen in the previous slide, all these payloads have a generic header and some specific field. So the format of generic header, payload header is shown here. The next payload field in this header is an 8-bit field which identifies the type of next payload. So when there is no next payload, the value of this next payload field is set to 0. Here we have to remember that there is no type field for the current payload. The type of the current payload is determined by the previous payload or the general header. Then the next one is the payload length. This is a 16-bit field which defines the length of the total payload including the generic header in terms of bytes. Then the next payload is a SA payload, the one which we have seen in the previous slide. SA is indicating starting of the negotiation. Starting of the negotiation. So this SA payload is used to negotiate the security parameters between the two communicating parties. However, these parameters are not included in the SA payload. they are included into other payload, that is proposal payload and the transform payload, which we have seen that the proposal payload contain the information during this starting security association negotiation, and the transform payload is basically define the security transform to create a secure channel. So the parameters which are negotiated at the time of starting of negotiation, they are not carried in this SA payload, but they are actually carried in the transform and proposal payload. The SA payload is followed by one or more proposal payload, because then it is actually carrying the parameters. And each proposal payload is followed by one or more transform payload. The SA payload just define the domain of interpretation field and the situation field. So let us understand the fields here. The field in the generic header, we have already discussed this next payload and the payload length. Then this DOI is a domain interpretation field. So this is a 32-bit field, and for phase 1, the value of 0 for this field defines the generic security association, and the value defines the IPsec. And then the last one is the situation, which is of variable length, that defines the situation under which the negotiation takes place. Then, as I told you, that this SA payload is followed by one or more proposal payload. Again, in the proposal payload, it initiates the mechanism of negotiation. So, although by self, it does not propose any parameters, it does define the protocol identification and the SPI. So, the parameters for negotiation are sent in the transform payload that follows, because proposal payload is followed by a transform payload. So each proposal payload is followed by one or more transform payload that gives an alternative set of parameters. Now in this proposal payload, we have the different fields like proposal. So the initiator defines the number for the proposal. So the proposal number is the field here, so that the responder can refer to it. Here we have to remember that the SA payload can include several proposal payloads. So if all of the proposals belong to the same set of protocol, then the proposal number must be the same for each protocol in the set. Otherwise, then the proposal must have the different number. Then we have a protocol ID. This is a 8-bit field which defines the protocol for negotiation. For example, which protocol we are using, IT phase 1, or when we are using it is set to 0. Protocol ID field. If you are using ESP, encapsulating security payload, it is set to 1. If you are using authentication header, then this protocol ID is set to 2. And then this SPI size is the 8-bit field which defines the size of SPI in bytes. Then the number of transform, this is a 8-bit field which defines the number of transform payload that will follow the proposal payload. And then SPI is again variable length field, that is the actual SPI. And note that if the SPI does not fill the 32-bit space, then no padding is added here. Then the next payload is the transform payload. So this transform payload actually carries the attributes of security association negotiation. So this is the format of transform payload. The fields in the generic header, this next payload, reserve, and the payload length, this we have already seen. Then the remaining fields here in the transform payload are, the first one is this transform number. So this is a 8-bit field which defines the transform number. If there is more than one transform payload in the proposal payload, then each must have its own number. Then we have a transform ID. So this 8-bit field defines the identity of the payload. Then the attributes, these are variable length. Each transform payload can carry several attributes. Now, each attribute itself can have 3 or 2 subfields. So the attribute type subfield defines the type of attribute as defined in DOI, that is domain interpretation. The attribute length subfield, if present, it defines the length of the attribute value. And the attribute value field, this is 2 bytes in the short form or of variable length in the long form. Then the next payload here is a key exchange payload. The key exchange payload is used in those exchanges that needs to send preliminary keys that are used for creating the session key. So, for example, it can be used to send a Diffie-Hellman half key. So, the format of key exchange payload is shown here. We already know this next payload and payload length field from the generic header, and this is a KE is a variable length field which carries the data which is needed for creation of the session key. For example, if Diffie-Hellman is used, this KE is carrying your half key. Then the identification payload allows the entities to send their identifications to each other. Here also the ID type is the 8-bit field, is a DOI specific, that is domain interpretation specific, and it defines the type of ID which is being used. Then ID data is a 24-bit field, which is usually set to 0. And then the last one is the identification data. The actual identity of each entity is carried in this variable length field. Then the next one is the certification payload. So anytime during the exchange, an entity can send this certification for public encryption, decryption keys or signature keys. So although the inclusion of certification payload in the exchange is normally optional, it needs to be included if there is no secure directory available to distribute the certificates. So the format of certification payload is shown here. The certificate encoding field is an 8-bit field which defines the encoding type of the certificate. And certificate data field, again, it is a variable length field which carries the actual value of certificate. Here we have to remember that the previous field which implicitly defined the size of this field. Then here the certificate type can be, as we have already seen, X.509 type of certificate for signature, X.509 type certificate for key exchange, or it can be a Kerberos token, it can be a authority revocation list, and many more different types of certificates are there. So these are the different types of certificate. So it can carry any one of these type of certificate. Then the next payload is the certification request payload. Each entity can explicitly request a certificate from the other entity using the certification request payload. So here the certificate type field is again the 8-bit field which defines the type of certificate as we have seen in the previous slide. And certificate authority field, variable length field which defines the authority for the key or for the type of certificate issued. The next one is the hash payload. The hash payload is actually carrying the hash value. So it is a data which is generated by the hash function as it is described in IKE exchange. So here the hash data is the variable length field which carries the hash data generated by applying the hash function to the message or the part of ISAKMP statements. The next payload is the signature payload which is carrying the signature data. So it is the data which is generated by applying the digital signature algorithm over some part of the messages or ISAKMP state. So signature field is actually carrying, it is a variable length field and it carries the digest which is resulting from applying the signature. Then the nonce payload contains the random data which is used as a nonce to assume the liveliness of the messages. So it is used for ensuring that the messages are fresh and they are not replayed by the attacker. So this nonce field is actually carrying the it is a variable length field and is actually carrying the value of nonce. So nonce are nothing but the random numbers which are basically used to ensure that the fresh messages sent every time and it is not the replayed one. Then the notification payload here is during the negotiation process, sometimes a party needs to inform the other party to the party of the status or error. So the notification payload is designed for these two purposes. The values here, the fields here in the notification payload are DOI, that is your domain interpretation. Then the next one is it is a 32-bit field and it is same as it is defined for the security association payload. Then here we have a protocol ID. So this 8-bit field is same as that which is defined for the proposal payload. Then we have a SPI size. This is a 8-bit field which is same as that defined for the proposal payload. Then the notification message type. The notification message type is of 16-bit field which specifies the status of the type of error that is to be reported. Then the different notification types are there which we are going to see in the next slide. Then we have a SPI. So this is a variable length field which is same as that of defined in the proposal payload. And the notification data. So the notification message type is there in the message type field and notification data is variable length and it can carry the extra textual information about the status of the error. So what kind of notifications can be there? It's like if the notification type is set to 1, it means that invalid payload type. If it is 2, it means that DOI is not supported, situations are not supported, invalid cookie, invalid major version, minor version, exchange type. Okay, so there are different types of notification for reporting the error condition. So this way the notification type and their values are set. These are some of the some more notification types. Then this is a status notification value. The status notification value 16384 is indicates that the status is now connected, and this one indicates that the DOI specific codes. Then the next payload here is a delete payload. So delete payload is basically used by the entity that has deleted one or more security associations from the security association database. And then in that case, such deleted security association needs to be informed to the peers that these security associations are no longer supported by the entity. Okay, so the payload fields are like this. First, it is carrying DOI, which is a 32-bit field, which we have already seen. Then the protocol ID, SPI, size of the SPI, number of SPI. Then this is a 16-bit field which defines the number of SPI. And one delete payload can report the deletion of several security association. And SPI, this is a variable length field which defines the SPIs of the deleted security associations. Then the last payload is a vendor payload. Here, the vendor payload allows the exchange of information which is particular to specific vendor. So here, the field vendor ID is a variable length field which defines the constant used by the vendor. So this is how we have studied about this ISAKMP protocol here, which is basically consists of which is designed actually to carry the messages for internet key exchange protocol by using these different types of payload which are there embedded in the general header.